We start by defining a flight mission. Simply draw the area we wish to survey. I'll put in 4 points here defining that area. Finish that element. Define takeoff and landing location. Finish element, and we now have a flight plan. We can view that flight plan in 3D. Reassure that we have it all correct. From underneath back to 2D, we see the flight plan. The next stage is simply to connect to the aircraft. It will upload that and fly it automatically. We then take from the aircraft the photographs, and we have a set of overlapped photographs. Each of these will be stitched together in the photogrammetry software. The next step then is to simply go into your photogrammetry software and start the workflow, add the photos. We would add all of these. And from there, these are the same photos we saw in that folder. From there, we set some accuracy parameters because we have corrected them so they're accurately located, and then simply go through here in a batch process and we can I'll just open a batch file, and then we can go through the process to align the photos, build the dense cloud, the mesh, produce a digital elevation model and orthophoto. The photogrammetry process, in this case Agisoft, builds a 3D model. You have a look at this model, rotate it around. We have a full 3D model of the site, accurate to centimetre level. We have digital elevation model as well as an orthomosaic, so that this orthomosaic looks like a photograph, but it is accurate to a few centimetres. You can overlay your design information on over the top of that. If you look back at the model, you'll see it's an interesting project, building a break wall and a harbour, which will be they're building a marina and housing and shops, etc. Alright, we'll have a look in some other softwares of some of these areas that are changing over time. On this site, we had previously surveyed the same area so that we could compare the survey information over time. This shows the earlier model. We have a model here, a digital elevation model and an orthomosaic at this particular point in time. If we have a look at this model again, we can see that it is a detailed 3D model. I might have a quick look at a stockpile in here, so I know that did change between epochs. So what we could do is we can go into the digital elevation model. That's the stockpile. We can get a quick volume on that from the software here by simply placing a area shape around it, and then I simply go right click measure. That's giving me profile across it and a volume. So, and then later we will compare the two elements together. You can take the 3D model produced by the photogrammetry into other software for visualization and editing. If we have a look at this, this area if we look here, we can see there's some plant been operating here. One of the things that we can do is very simply eliminate that from the scene to give us a better terrain model. Now I'll just rotate that so you can see what happened. If I undo that and redo it, we simply collapse that back onto the terrain so we can tidy up elements out of your terrain model. Now that we have two surveys of the same area, we can quickly compare the surfaces and the models. Here we have the first survey, detailed out. This is the orthomosaic. We can have a look around that, and I can turn on the second one. So here we have the second. Okay, so fairly quickly have a look. There's a good example over here. If we looked at some of this here, if we looked at this area here, we can see this was construction going on. If we go to the second epoch, we can see the progress on that construction. Also, I know there's a stockpile of material near the roundabout here, this stockpile here, which is there in the first survey and basically cleared in the second survey. So we can also look at this in 3D. Looking at it in 3D, we can see just off this roundabout the stockpile right here. Now if we were to have a look at that in the second epoch, you will see that that particular stockpile has gone away. Okay. Another way to compare surfaces on a more detailed level is to actually create a chain surface. So I've created a surface of part of this area that is the difference between the two surveys. I can then contour that survey, that surface, and that produces what I call isopachs, so contours of difference. So you can quickly come in and have a look, and you can see these are I think 1 meter contours. Now scrolling down here reveals that stockpile that we were looking at earlier. We can see that there's around about a 5 meter difference according to our isopachs. We can see if I turn on the second survey, basically that's gone. So we're looking at the second survey overlaid with contours of difference from the first survey. There's a wealth of information contained in this. You can also easily measure the volume between surfaces, between first survey, second survey. There's a tool here, and it's measure between surfaces, between this surface and that surface, and I'll limit it to an area of interest to that particular area, and that will then go and measure the volume in that area, give us cut volumes, fill volumes, etc. Okay, thank you.